This video tutorial presents a generic experimental procedure. Please consult your class notes for term-specific instructions. This week's lab will focus on the refrigeration cycle from thermodynamics. This diagram shows the four main components of the cycle: a compressor, condenser, expansion valve, and evaporator. The four nodes are mapped on the TS diagram using measured values of temperature, pressure, and flow rate. The Hampton training cart provides a working model of the refrigeration cycle and commonly used to train HVAC technicians. You'll notice the cart has two evaporators to simulate two zones, such as a refrigerator and freezer. For this lab, only Zone 1 is active. The cart is instrumented with 5 pressure transducers and 16 thermocouples to measure pressure and temperature throughout the circuit. Additionally, a sight glass and electronic flow meter measure the freon flow. Be careful, the latter is only accurate when the refrigerant is a saturated liquid. At first, the cart can be overwhelming. We recommend physically tracing out the circuit. Start at the compressor outlet and follow the freon path by tracing the copper tubing over to the condenser. After passing through the condenser, the freon will loop around and will eventually pass through the 2 flow meters before moving on to the expansion valve. Then the freon flows onward to the evaporator. Use the sight glasses to inspect the freon state, i.e. liquid or vapor, entering and exiting the evaporator. From the evaporator, the freon returns back to the compressor to complete the circuit. Use the weather station to measure and record the lab environment. Toggle the power switch on the cart. Then turn on and set the fan speed for the condenser and evaporator number 1. Full clockwise is low speed. Use the anemometer to measure the airflow through the evaporator and then through the condenser. On the desktop, open the ME X95 shortcut folder and select AC Monitor. LabVIEW will take a few minutes to launch and will open with the main window. Select the User Input tab. You may optionally enter values for the various fields, which will automatically be included in the data file. Let's return to the Monitor Temperatures tab, then start LabVIEW by clicking the white arrow in the top menu bar. LabVIEW will begin to chart the temperatures measured by the 16 thermocouples. Press the forward button to start the compressor. Then use the yellow up-down arrows to adjust the compressor speed, which is measured in hertz. For this example, we're going to crank up the speed to 60 hertz, which equates to 100%. FYI, some carts only go up to 59 hertz, and that's fine. In LabVIEW, you should see the temperature suddenly become transient. You'll need to wait until the temperatures level out and attain a steady state before taking any measurements. This will take around 20 minutes. Inspect the sight glass flow meter during this transient period and notice the freon is a mixture of vapor and liquid. Please note the electronic flow meter monitored by the LabVIEW is only valid when the freon is a saturated liquid. Also, please note the power meter is only applicable for the compressor, not the fans. While we're waiting for steady state, let's return to LabVIEW. Click on the Monitor Temperatures 2 tab and notice how the graphs are separated by component for easier viewing. The next tab displays graphs of the pressure, flow, and power measurements. Okay, let's return to the original Monitor Temperature tab. Periodically, monitor the various sight glasses located around the cart and note the state of the Freon. As the system nears steady state, you'll notice the flow meter becomes more stable. Once steady state is attained, set the buffer to the desired sample size. 50 works well. Then click the Save Data button. LabVIEW will take repeated measurements of all the instrumented channels until the buffer is full. Save the data to the desktop using a descriptive file name. Here's a sample data file opened in Excel. The optional user input is displayed in the header, followed by a statistical summary of the channels: temperature, pressure, flow, and power. You'll use this data to map out the TS diagram of the refrigeration cycle. When finished, please shut down the cart. Turn the evaporator and condenser fans off. Then reduce the compressor speed to around 10 Hz before pressing the stop button. Finally, toggle the power button on the cart. To end LabVIEW, press the End Program button and close LabVIEW. Remember to save your data before leaving the lab today.